We can start if you want. Our first talk of the day will be in charge of Fabian, who is going to talk us about Astro COLIBRI. Then, Fabian. Go ahead, please.
Now you should be able to hear me.
Yes.
Very good. Hi, everybody. Thanks for giving me the opportunity to talk today and changing the program on a short time scale. I also apologize to the French colleagues who might certainly have seen a very similar presentation recently, but yeah, we'll see. So what I'm going to present is the Astro COLIBRI platform, and I'm certainly aware that the name of this new tool causes confusion, especially in this domain, because of the COLIBRI telescope that I know pretty well. Visited it a couple of weeks ago, but yeah, the two tools. One is a software, one is a hardware tool, have been developed in parallel without thinking too much, at least on our side, on how to name that. And it's a tool that we have been developing at IRFU and at CA in near Paris with help from people in Germany and funded by the AHEAD 2020 program in Europe over the last years. So I'll tell you a bit about what you can do with that and a bit of an advertisement. But before diving into the tool, and given the topic of this session today, also later on focusing on neutrinos, I thought like going back in time and tell you a bit where we came from and why we developed this tool. And basically for us, or for me, the story started in 2017, where IceCube detected another high energy neutrino, sent out an alert to follow-up observatories at all wavelengths. We triggered follow-up observations, for example, with HESS, something I'm responsible for pretty shortly. We observed for a day or so, or one night, and didn't see anything. That was the story for us. Then, of course, you all know how the story went along. Almost a week later, Fermi-Lat put out an ATEL and mentioned the detection of an active blazar within the neutrino uncertainty region. That, of course, stirred up a lot of interest, especially because this blazar wasn't just there, it was active, and much more active than in archival data in high energy gamma rays, but also in other wavelengths, optical X-rays, etc., with again unprecedented flux levels. So this was the first and so far only relatively significant coincidence between a high energy neutrino and an active source in other wavelengths. And of course, caused significant interest in the community with an additional multi-wavelengths campaign starting afterwards, and quite a few interesting interpretation papers. So this is all history. What caused us to work on a new tool is, if you look a bit behind the curtain and think about how this nice observation and detection came about. It always bothers me that it took 6 days between the detection of the neutrino and somebody realizing that there is a blazar and that this blazar is doing a flare within the localisation uncertainty. So this is just a fact. And if you go back in time, what people needed to do and still need to do to get to that conclusion is to do a cone search within the neutrino uncertainty region in catalogs of known sources, for example, the 4FGL catalog of Fermi sources or any other source catalog of your preference. And then you'll find immediately that there is an interesting source nearby. And then you need to check the state of that source, and that you can do in the Fermi automatic analysis called FAVA. And the light curve you've seen here all along. So this is the publicly accessible light curve from Fermi from that source. All these tools and catalogs and FAVA, for example, are public and were public at the time. But of course, you had to access them manually. You had to add your own scripts doing these cone searches. You had to go to the FAVA website. You have to copy and paste the coordinates in there and do all that by hand. And that was and is tedious, and therefore it took a long time until somebody did that. So there clearly we saw the need for automatization, providing interfaces to these nice tools and all this plentiful information that is available in the multi-wavelengths range and nowadays, of course, the multi-messenger domain. So that's the main idea of our platform. The idea is to be the central point where you listen to all kinds of interesting alert streams and detections of transient phenomena across the wavelength range, across multiple messengers. We mentioned neutrinos, of course, gravitational waves, etc. You combine all this information in a central point, provide an easy to understand interface to these events, so you don't have to go through emails or read XML files and view events and all these things. And then use this central point and easy to use interface to access the wealth of additional information like catalogs, like the FAVA information, like SED builders, Aladino, ESA, sky maps. You can overlay catalogs and things like that. So all this information is there, but then we have a single point of entry, and you can just click on them, and you don't have to copy and paste coordinates and things like that. So that makes our life much easier, I think. And that's what is Astro COLIBRI. So that is this automatic pipeline providing this easy access to the most interesting transients of all kinds and types. It also has a central API that you can access to these cone searches from your own system, and it provides these interfaces that I highlight in the following. The whole thing is relatively new. We released the first major public version in August and have now about 400 users across all platforms. There's a paper that we published in app.js that you can find under this link, or just search for Astro COLIBRI, and a few conference proceedings that describe a few use cases and more specific details. The idea is now to show you a bit, without going too much into the architecture and the technical details that go on behind the curtain, just knowing that we have this central cloud-based API that connects to all kinds of databases and external information, external APIs, and listens to the usual stream of alerts and detections like GCN, etc. And that feeds then a front-end layer with clients that run both in the web and on your smartphone, so it's on iOS and Android. And I show you a few screenshots so to get an idea of what you can do with this tool in the following. So if you go to astro-colibri.com, you end up on a website that looks almost like that. The screenshot is a couple of weeks old. We changed a few minor details in the meantime. And there you see a few aspects. So the first thing that you see is a sky map of the latest transients. So all the latest interesting events are given there in a sky view. The marker colors refer to the detecting observatory, and the shape of these markers refer to the type of the event, so if it's a GRB or a fast radio burst or neutrino or things like that. And then you get the same information also in a list that is ordered with decreasing dates. And for this example here, I go back in time to this neutrino event in 2017, and this is then highlighted here, and you get the first information about this event, its coordinates, its uncertainty, and detection type here in this list directly. More interesting, why does it not move? Is to get at the same time a quick overview over the main parameters of each event. To get the name of the event, you get again the coordinates, and you get, for example, the astrophysical probability for a neutrino and the energy. You also get the false alarm rates and things like that. To get at a glimpse, you see if this event is interesting for you, and if you want to dive deeper into it. If you decide to do so, we have this list, and this is built on the fly depending on the type of the event and the available information for each event. I have a long list of links to these external resources that I mentioned earlier on. So you can, for example, directly click on the FAVA, and then you're redirected to the FAVA information, so the Fermi online reconstruction of that particular position in the sky. You get access to the GCNs, you get access to Toby, which is a nice tool showing you the schedule and visibility of all major satellites like Chandra and Swift and things like that. So if you want to trigger follow-up observations with these, you can get the information right away, and you get all the other usual suspects of tools people use to learn more about individual events directly there with a direct link. At the top of the interface, you get a few buttons where you can first of all personalize your interface. You don't have to create an account. You can use that out of the box. But if you create an account and then log in, all the settings that the filter settings, etc., will be stored and will be synchronized between devices. So if you change from the web view to a smartphone app and log in on both with the same account, everything is nicely synchronized. You can also have this location button where you can select your location on Earth from a list of the main observatories, including San Pedro Martir, of course. And then you can select your favorite observatories, and all the visibility plots that I'll discuss in a second will be directly calculated for your favorite observatory. If you have an observatory that is not part of that list, please let us know. We are very happy to include that. Or you can also enter your longitude, latitude, and height directly, and it should update you. If you want to have more information, there's this information button there, which brings you to a dedicated website, which has links to our papers, which has links to the app stores, which has links to the documentation of the API, changelog, things like that, linked to merchandising and all this fun stuff. Then I mentioned this legend here already. At the left side, there's a filter button. If you click there, you get a selection of filter criteria. So by default, we always show the last month of transients. If this is too much for you, or you want to see more, just use these settings there. You can also select down select events that are interesting for you. So if you're not interested in GRBs, to just deselect them, or any other types of sources if you want to focus on a few events. Next thing is you you have selected one of these transients, you want to put it into context. Again, here very helpful in the case of a neutrino alert. You have at the top this switch between the view of the latest transients and the cone search. So if you switch to cone search, we do just that. We search in a few catalogs like 4FGL, and then catalogs of soft gamma repeaters and anomalous X-ray pulsars, so a few galactic sources around the region of interest. So by default, that's done in a 10-degree circle. Here you see a zoomed-in view where the black circle is the uncertainty region given by IceCube for that particular event in 2017, and then you see immediately that around this uncertainty region there are fewer 4FGL sources, but particularly there's one very close by, and that's of course the TXS 0546 source. And then you can click on this source, and then you get this information box updated with information and the name of the sources and things like that. So you see immediately where this source has been detected and which catalog, and you get links to TEFCAT now and all other kinds of catalogs for this particular source. So you can rapidly check if the sources found nearby an interesting transient are interesting for you, and if you want to trigger follow-up observations. If you decide to do so, I mentioned this choice of the localization and of the observatory. This influences this region at the lower right of the front end, where the visibility plots are calculated. So if you click on this, you get a zoomed-in view. There you see immediately the dark time for the current day. For example, now it's the Hess observatory being selected, and you see the altitude of your source rising and then falling again. You get an indication of two altitude limits, which are typical for an IACT, in that case 30 and 45 degrees. And then you get the visibility range above that altitude directly written on the plot, so you can immediately read off for how long and in which time interval you would be able to observe that source under a certain condition. And then, of course, you can then directly feed into your scheduling system of your favorite observatory, or can call your shifters or things like that. There are other complications that you can that are implemented here, like moonlight observations, where the moon is above the sky, but you would still be able to observe. And this, of course, then depends on each observatory. And we have implemented a few of these special observing criteria. That brings me to a summary. So we have this overall pipeline, listening to monitoring satellites and observatories, so the usual suspects. We work very closely with SWAM to implement that once it's launched, and also to be used potentially for the burst advocates within the observatory. All this information comes to us through a range of brokers and data streams. We are listening to these in real time, fill our database, and to then push that information in real time to the front ends. I briefly mentioned that the front ends are available on the web. That's what I've shown you in the last few minutes, but the same information, exactly the same information, is also available on smartphones. So you can use that when you're out and about. The additional advantage of the smartphone app is that you get push notifications that you can subscribe to. So there's a settings menu that you can open up and then subscribe to push notification streams dedicated to certain types of events. And each time we get one of these events, you get a push alert, which avoids you to read your emails constantly for uninteresting new events. That's it. So again, feel free to use that. Let us know feedback, bugs that you find, other things that you would like to see in a tool like that. We'll be happy to help you there. So the web interface is there, and then just search for the app in your favorite app store. If you want to get some more introduction and a few tutorials, you can find us on YouTube, and we even have a Twitter stream nowadays. That's how you do things, apparently. That's it from my side. I'm happy to take questions.
Thank you, Fabian. Amazing. I'm downloading the app right now. Questions, please raise your hand. Please, Denefeld.
Michel, you can give your...
Michel? Michel?
No, he's fighting with his computer, probably.
Ah.
No, I don't know what happens to Michel. Michel, you can type your question if you want in the chat. Oh.
Or otherwise, just send me and the developers in an email if you have a precise question.
I have some suggestions, Fabian, to be honest, and I will send to you directly because I've used your application. So
I hope it's working. Very good.
No, it's very impressive.
Thanks.
It's amazing and works perfectly in my phone.
That's good to know.
Questions, suggestions, comments? So what's your plan for the future? What are you?
I mean, we have a long list of features that we want to implement and how to improve the interface and new information to add. I wouldn't know where to start, but certainly one thing that is coming up, of course, until 1 year or next year, is to improve the handling of gravitational waves. So if you select a time range during the run 03, you can see that we have implemented the display of gravitational wave maps, the contours there, but that currently slows down the whole interface quite a bit because the data is quite significant, so we have to improve that. And then also see how we display the potential counterparts and galaxy catalogs and things like that, which are useful for scheduling follow-up observations of gravitational waves. But yeah, that's only one out of, I don't know, 65 issues that we have currently and ideas and things like that. So we are constantly working on that. And we do that both for professional astronomers, and there's quite a big interest in the amateur astronomy community. So we are in contact with many of these associations and groups that combine amateur astronomy, and they're interesting to following along the time domain astronomy more and more. So there's certainly also a few improvements coming along, which adds more information to the events and tells people what a GRB is, for example. I mean, we have a short description now, but it's certainly things we can improve.
That's great. I was thinking because we can discuss later if we can send you, for example, the coordinate that we are observing with DOTI or Quadly, and you put the information in the page
Sure.
maybe to
sure,
show
yeah.
why are the fields that we are observing or follow up with the live observation. Then would be great. Wow,
Yeah.
I'm really amazed. Thank you. More comments, questions? If not, Enrique, please.
Quick comment. You should try to convince Von to share the data there.
Oh, it will be. I mean, the swarm alerts will be public, right?
Okay.
So they will show up at the same level as the Swift and Fermi GRB alerts, for example.
Okay, great.
Arnaud can confirm if you want to have details. Arnaud can give, but I confirm the comments, the comment of Fabian.
Great. Awesome.
And there's the question from Michel Dennefeld, how we do the categorization of the alert. So we don't do categorizations ourselves because we don't want to dive into the physics interpretation of events. So we only rely on external information. So for example, tidal disruption events, if they're classified as such in the TNS, the transient name server, then we would add the event and show it as such. And that's why we have a bunch of events that are given as bursts, where we just show that there's a burst of emission detected by some observatory, but it's not characterized as a GRB yet, or as a tidal disruption event, or something else. So that's why we rely on the experts in some sense to do the characterization and the categorization for us. I hope that answers your question. Otherwise, just let me know offline.